right. Happy Tuesday, 8th grade. I'm going to try making my own videos for this topic, which is types of chemical reactions. Now, when we talk about chemical reactions, we're talking about things that cause chemical change or an actual change to what you started with. So if you started with salt and bromine, for example, like table salt and bromine, and you got a different type of salt and chlorine left, that would be a chemical change, as opposed to a physical change such as tearing up paper. So the 5 types of chemical reactions are formation or synthesis reactions, decomposition reactions, combustion reactions, single replacement reactions, and double replacement reactions. So, formation reactions, otherwise known as synthesis reactions, are when you combine 2 elements to form a compound. And one of the easiest examples of this would just be table salt, where we take solid sodium compound and add chlorine gas, and we put them together and we get a solid sodium chloride. Decomposition reactions are basically the opposite of formation reactions, where you take one compound and you break it down into 2 or more simpler compounds or elements. So the example they give here is what's called electrolysis of water, which is when you literally shoot electricity through water and break it apart so it becomes its original gaseous form, but not just like water vapor or anything. It would be separate oxygen and hydrogen gas. Hydrocarbon combustion. So a hydrocarbon is any element that has the formula carbon and hydrogen. So it can just be as simple as CH, although that doesn't really exist. The simplest, I believe, is ethane, which is CH4. So 1 carbon and 4 hydrogens. But the letters N there represent that they could be any number. So it can be CaH8, it can be whatever combination of numbers you want, but as long as it has C and H and that's all it has, it can react with oxygen gas, and usually you need to add some heat or energy to this reaction so that it basically goes bang and you get carbon dioxide and water vapor plus some thermal energy. This is the reaction that occurs in your gas tank so that you can get energy to move your car. So there's 2 different types of combustion. I just want to go briefly over this because all you really need to know is combustion reactions generally. But complete combustion is when there's plenty of oxygen for the hydrocarbon to react with. So all of the hydrocarbons get burned into carbon dioxide and water. This is in contrast to incomplete combustion, where there's not enough oxygen for this, and you end up producing some carbon monoxide gas, which is a highly toxic gas to humans, and it's colorless and odorless, which makes it even more dangerous. So that's why, I don't know if this has ever happened to you, but if you ever run your car for a little bit to warm it up, you have to make sure it's either outside or that the garage is open and the air is free flowing. You don't want to burn any fuel without proper ventilation, like it says in the bottom, because otherwise there won't be enough oxygen to make a full, complete combustion reaction, and you will start producing carbon monoxide. All right, so single displacement reactions. A single displacement reaction is a chemical change that involves an element and a compound as your reactants. And what will generally happen is the element will take the place of one of the parts of the compound. Like it says here, one element displaces or replaces another element from the compound. So single displacement reactions have a general formula. There's going to be a lot of letters here, but I'll try to explain as best as I can. So basically, you either have a metal and a compound, and basically the metal takes place of the other metal, and you're left with the other element gone, like as a separate, and it says metal always replaces metal. So an example of that would be if you took calcium and put it with sodium chloride, and then you got calcium chloride plus elemental sodium. The second case is when you have the non-metal being replaced, which an example of that would be if you have sodium chloride once again, but then this time you have elemental bromine, you'll get sodium bromide plus elemental chlorine. So here's some more examples. If you have a coil of magnesium ribbon placed in a solution of silver nitrate, you end up getting elemental silver plus magnesium nitrate. So that, once again, you have elemental magnesium, which is the metal in this case, plus the compound silver nitrate. Then you add the coil of magnesium to the silver nitrate, and then you get elemental silver to fall out, plus a new compound, magnesium nitrate. Another example, this is kind of similar to the one I was talking about with sodium chloride and bromine. So this time we have a nonmetal, like bromine is a gas in its natural state, combined with calcium iodide, the compound, and we get elemental iodine, which is also a gas, and the bromine has now replaced the iodine and made calcium bromide. This kind of leads us to our next thing, which is double displacement reactions. I feel like these are a little simpler to understand than a single replacement, because basically everything gets swapped around. So you start with a compound plus a compound, and you get the metal with the non-metal you get the first metal with the second non-metal, and then you get the second metal with the first non-metal. Everything just flip-flops, and it's a giant mess that makes some cool things. So you don't mix up the, you don't put the metallic elements next to each other, nor do you put the non-metallic elements next to each other in a double displacement reaction. What'll happen is it'll always be metal plus non-metal in a double displacement reaction. An example here is lead 2 nitrate and potassium iodide. So you have your metal, lead, with your nitrate, which is a nonmetal, plus you have your potassium, which is metal, with iodide, which is a nonmetal. You swap who has which nonmetal, and you get lead 2 iodide plus potassium nitrate. So hopefully this all makes sense. If we have any questions, of course, feel free to email me or maybe even comment on this assignment on Google Classroom. We will most likely be doing a review of this again on Thursday during our Zoom lesson. So otherwise, have a great day, 8th grade.